This video is oriented to demonstrate the capabilities of the big data clustering, load profiling, and customer segmentation tools. These tools have been developed in the scope of the eDREAM project. This big data layer is divided into three different services, which are the load profiling tool, the big data clustering, and the customer segmentation tool. However, the data pipeline is much more complex and requires several stages to deliver valuable results. During the eDREAM project, we have collected anonymized data from more than 500 users. Unfortunately, this raw data must be pre-processed before we can fit our algorithms with them. This data pre-processing comprehends, as we will see, the tasks of data cleaning and filtering, identify and remove outliers, and finally, locate and extrapolate missing values. Once the data is ready, we can pass them to the load profiling tool. This tool is capable of calculating up to 11 different load profiles depending on the selected model. Just as an example, option 1 will calculate a daily profile with 15 minutes granularity. Regarding clustering tools, we have developed and implemented a self-supervising deep learning algorithm. The neural network architecture is based on an autoencoder model, but on top of it, we defined and added a new clustering layer. After the training stage, which is needed in all machine learning models, the tool shall group the users in the number of clusters previously defined by the operator. In this particular case, the selected number is 4. The customer segmentation tool is a supervised deep learning algorithm that can classify new users into the previously calculated clusters. After training the tool, it can offer pretty good results, scoring an average accuracy of more than 95%. The tools presented until now are backend oriented and designed to support machine-to-machine communications. However, these functionalities can also be requested through a REST API. In this first example, we are requesting to the clustering tool to clusterize the whole dataset based on daily profiles. Or another example, this time clustering weekly profiles Monday to Sunday and using k-means instead of the autoencoder as the clustering algorithm. This final example of the clustering tool is a little bit different. This time we are requesting it to cluster not the user's demand, but their flexibility. So we select the 11th option and, once again, the k-means algorithm. Finally, we can also limit the clustering to a specific time frame. To finalize this demo, we will simulate that we want to classify a couple of new users into the previously defined clusters. So, we send to the customer segmentation tool the user's ID and the time frame. The algorithm answers back with the cluster level of each user. We can see that the different users are classified into two different clusters.